Hey guys, so today's lesson is all about using your calculator to kind of find these approximations for your ratios, your trig ratios, and the unit circle. Now, obviously, what we've been looking at lately is just looking at 30, 60, 90 triangles and 45, 45, 90 triangles. But there are obviously lots of other different triangles that you could draw in the unit circle that have a different reference angle. So if I drew a triangle in quadrant 1, it could have an angle of anywhere from between 0 and 90 degrees. But we don't really have a way to calculate, because those aren't special triangles, to find the actual sine value of 80 degrees. So today we're going to be using our calculator somewhat to find those things, but we'll also be looking for particular angles that would give these ratios. So today is actually an important day as far as notation wise. So understanding that every time that you're plugging in some angle and evaluating the cosine of 60, the cosine of 20, what you're getting back out is a ratio of side lengths. You're looking for this particular opposite side or adjacent side of your triangle, and every time that we're looking for if we're given a ratio, we're looking for the angle that would give that ratio. So today, again, that notation and understanding the difference is pretty important, but also just knowing how to plug things into your calculator too. So our first one is something that we should be comfortable with. We should know how to find the cosine of 60. That is a special angle that we can find an exact value for. So the cosine of 60 would be in quadrant 1. This would be my 60-degree angle. This would be my 30-degree angle. So that means that this side across from my 30 degree is 1/2, and this side across from my 60 degree is root 3/2. So my cosine of 60 would just be my adjacent side, or my x value would just be 1/2. Now we can check that in our calculator because we can type those things in. Yeah, you have to make sure that you are putting in the right mode. So for mine right now, I'm in radian mode. I want to make sure that I'm in degree mode, so when I evaluate it, I'm actually getting the correct ratio. And if I type cosine of 60, I get 0.5, which is my 1/2. So for this first part, we're going to be looking at things that, like this one, we could find using our special right triangles, but if it's not a special right triangle like this one, then we actually can't find that using the same method. So this is something we would have to calculate. All of these ones, 1 through 5, are things that we have to actually find in our calculators because they're not part of our special right triangle relationships. So we're just going to plug some stuff in. So I'm looking for the tangent of 56 degrees in 60 minutes. Remember that if you're doing that, you have to go into angle, or you might have a different, I'm using my graphing calculator, but if you have the different one, there's ways that you can do that DMS stuff. So for this one, I get 1.5398. I'm going to round to 1.540. We'll round to 3 decimal places. For cosecant, obviously there's not a cosecant button in our calculator, but we know that cosecant is the opposite, or the reciprocal of sine. So what we're actually evaluating here is 1 over sine of 24 degrees. I type that in, and I get 2.45, and again I'll round to 3 decimal places, so 2.459. This again is a ratio. So ratio of side lengths. This is an angle. So you need to make sure that you're aware notationally of the difference between those things. What we're getting back out, again, is some side length of a triangle. Okay. Cotangent. Again, not a button on our calculator, but I know that cotangent is 1 over tangent of 37. And that's something I can type in. So 1 divided by tangent of 37 degrees would give a ratio of 1.327 rounded to 3 decimal places. Section's a little bit weird. 1 over secant. Well, we know secant's already 1 over cosine, so this would be like 1 over cosine of 58. Which, when we have like this fraction and then something else that's in the denominator, if I multiply by the reciprocal, really what that means is I'm looking for the cosine of 58. 1 over secant of 58 is really cosine of 58. So I'm going to plug that into my calculator, and I get 0.5299, so 0.530 rounded to 3 decimal places. Again, this is some ratio, so like pretending that this was in a triangle, this would be my 58 degrees. My cosine would be the side length of 0.530. Okay, and then we could use Pythagorean theorem to come up with the other side length, so I could find my sine given that my cosine is 0.530, but that's not necessary for this problem. We're just evaluating or approximating our values here. And the last one, as far as like straight plugging into your calculator is concerned, this notation again is a little bit different than you like can't actually plug it in exactly like this. So if I'm looking at cosine squared of 27, that's the same thing as cosine of 27 quantity squared. So that's how we're actually going to evaluate in our calculator. Cosine of 27 quantity squared. Make sure that you do like that double set of parentheses because it'll automatically put that parentheses around the 27. And we should get then 0.079, 3 decimal places, 4. So that's part is pretty easy, just kind of plugging into your calculator and making sure that you're aware of the difference. This next part, we're actually looking for the angle. So this time we're given a ratio, we're given a side length, and we're coming up with the angle that would give that side length. Now we've already done this part in on your first test even, and we've talked about it several times. What we're doing too is also restricting some of the angles that we're looking for in between. This really just tells you what quadrant we're looking for. So this is in quadrant 1. So we're trying to decide, okay, is there a ratio that would give tangent of theta is equal to 1 in quadrant 1? And since we've already done this one before, it was on like your quiz and on your test in the first chapter, this theta value that would give that would, so if it's 1, that means it's sine over cosine. Sine is equal to cosine. That happens when you have a 45, 45, 90 triangle. So this reference angle here, your theta, would be 45. And you can double check that. So like in my calculator, I could type in tangent of 45, and sure enough, I get 1 back out. So again, I'm looking for what angle gives that. Okay, what about this? Let's see. We have cosine of theta is negative root 3 over 2. That means that we're dealing with some 30, 60, 90 triangle. That's one of the ones that we know. And the tangent of theta is less than 0, which means that's negative. So cosine's negative, tangent's negative. That means that our triangle here is in quadrant 2. Okay, so knowing that we are in quadrant 2, we want our cosine to be negative root 3 over 2, which is our x value. Again, this is a 30, 60, 90 triangle, so this angle up here is going to be our 30 degree or 60 degree angle because we're across from the root 3 over 2, and across from my 30 would be the 1/2. So if this is my 60 degree angle, my reference angle really is at 30 degrees, and since I'm in quadrant 2, I want between 90 and 180, so I'm looking for what this angle would be. This is my theta that I'm looking for that would give that, that ratio that's also, again, negative. Okay, so to find that, we kind of do that backwards version of what we did before. So if I gave you like sine of 120, you could draw your reference angle in quadrant 2, or draw your reference triangle in quadrant 2, and then come up with your reference angle by doing 180 minus that. This is the same idea, we're just going in reverse. We're coming up with what the angle would be given the reference angle. So still I'm going to do 180 minus 30, which gives me 150 degrees. So that's really my theta. That if I was looking for cosine of 150, I would draw a reference triangle in quadrant 2 because that's my angle that would give it in quadrant 2. My reference angle would be 30 degrees, which would give my cosine of negative root 3 over 2. So there's a lot of like backwards thinking here. We're coming up with like the reverse idea that we've been doing the last couple days. Same idea for this one. We're looking for where cosine is negative 1. So if we have cosine giving negative 1, here's our unit circle. We're looking for an x value of negative 1. Nowhere on like in between our unit circles will give that. This only happens at a quadrantal angle. So here it's at 1, 0. Here it's at 0, 1. Here it's at negative 1, 0. And down here it's at 0, negative 1. So our cosine giving negative 1, which means my x value is negative 1, which happens over here at 180 degrees. Okay, so there's that idea as far as like on the unit circle is concerned. But again, sometimes we don't have things that are just perfectly on a special right triangle on the unit circle, so we have to come up with a different way to do that. So We talked about this in geometry. But an inverse trig function is a function that finds the angle. It's something that undoes another function. So if I was looking for this angle theta and this ratio, this is not a ratio that we're familiar with on the unit circle, but that doesn't mean that it doesn't exist somewhere out there. So we're looking for the theta that would give that. Okay, so I just want to draw a quick sketch of what this looks like. So if this is my theta, this is what I'm looking for. This would be my opposite and my adjacent side. And so I can come up with that ratio of sine of theta equals 3 over 4. But to actually find that angle, what we have to do is undo sine, because sine is some function. Now when you undo a function, you do what's again called the inverse. So this happens in a couple different ways. Like I can find, say, let me pretend that this is true. So this is kind of off as a side note. If I know the square root of x is 2, I can come up with my x value by squaring both sides. And what that does is it cancels out the square and the square root and the square. Square root and square are inverses of each other because they cancel each other out. And then we get left with our answer of x equals 4. That's what this inverse does. So when we take the sine inverse of both sides, just like we square both sides here, my sine inverse and my sine will cancel, and I'll be left with theta, just like I'm left with x on this side. And then on the left, sorry, that's the right, I'm left with then like 2 squared. I'm left with my inverse function, which in this case was square, but in this case it's sine inverse. So in my calculator, the sine inverse button is located right above your sine, cosine, and tangent. You'll see like the little -1 pieces. So I type in sine inverse of 3 over 4. And I get theta is equal to 48.59. So that would be the angle that would give that ratio. So I could try it. I could do sine of 48.59, and I should get 3 over 4, which is approximately what I get, that 0.75. Obviously, this was a rounded answer, so we're not getting exactly 3/4, but close enough. So this is like kind of this notation that I'm talking about, that every time we take sine inverse, so normally we take sine of an angle and we get some ratio. That's what we did on the front side. This was always some angle that we're approximating, we get a ratio of side lengths. This time though, we're taking the sine inverse of a ratio and we are getting an angle back out. Okay, so it's the opposite than our normal sine function. So now that we've done that, I want you to try example 10. So I'll draw out the triangle. If you've paused the video, that's a good thing. You don't necessarily need to do this step to actually find the triangle, but it might be helpful. I don't know. Helps you at least remind you what you're looking for, which is theta. So to come up with theta, we have to take the inverse of both sides. When we take the inverse, the tangent and the tan inverse will cancel out. I'm just going to write it in one step, but you can show like the step that we did above. And if I take tan inverse of 5 over 9, I get a theta value of 29.05. When we do stuff with secant and cotangent, it gets a little bit trickier because we don't have like a cosecant inverse function on there. But my recommendation is that you change it right away to 1 over cosine. And we've done this before, that if I have a reciprocal on one side, to make that not a reciprocal anymore, if I just really want cosine, so if it's 1 over cosine right now and I really would just want cosine back out, then I have to take the reciprocal on the other side. So these are identical, these are equivalent relationships. And again, since I'm solving for that angle, I got to undo cosine with the inverse. There we go. And then that's what we're typing into our calculator. Oh, for 1.49. 1.4923. And that'll spit out at us 47.92 degrees. Okay. It's important that for this one primarily, it's not the same thing. Like you can't do a lot of people want to do that. That's not true. Okay, that actually won't work because this ratio, remember, like this is sine inverse of some ratio. There is no cosine no angle that will give you 1.4923 because that's out of the range. Remember, the cosine range is from -1 to 1. So this will give you an error in your calculator. And if you do get that error, that means that you're probably evaluating these things wrong. Okay, so make sure that every time that you're doing these ones, instead of jumping right to that answer, it's really, really important to switch to the primary trig function. So switch to sine, cosine, and tangent because those are the only ones that you're calculating or your calculator will do. And then that'll allow you to actually do your solutions and come up with your angle. And know that there is a difference. So secant of 1.4923 will give you a value. So will secant of theta of 1.4923. Like some of those are two different things. This is what's the angle that gives this ratio. This one says what is the ratio at an angle of 1.4923 degrees. Okay, so these are two different questions. And you have to make sure that you know the difference because notationally speaking, they look really similar, but you have to make sure that you're knowing like what's inside the parentheses, when do I use an inverse, when do I not, when am I looking for reference triangles, when am I not, that kind of idea. That's probably the hardest part of this section. Like the whole calculator stuff is pretty easy, but if you get mixed up on the notation of what you're actually solving for, that can make your life a little bit difficult. Okay, so a big idea, really, honestly, for this entire chapter, this entire section here, this lesson, is this idea. Knowing that when you take the inverse, you're taking the inverse of some ratio and you're getting an angle back out. Inverse, angle. If you're taking the sine, the trig function of an angle, you're getting a ratio back out.